Let's do alkenes, please. Let's do alkenes. Alkenes are hydrocarbon with the, do this, C double bonded to C. This thing means carbon-carbon, please. This thing means carbon-carbon. With the, this double bond, with the, this is red, carbon-carbon double bond, please. Alkenes are hydrocarbons with the, this is red, carbon-carbon double bond. What's red? With the carbon-carbon double bonds, and have the general formula CnH2n. And have the general formula CnH2n. Full stop. This man, please, is it saturated or unsaturated? Take down, please. These unsaturated hydrocarbons, are these, These, these. These unsaturated hydrocarbons are isomeric, that means they're isomers, are isomeric in brackets, have the same molecular formula. Close the bracket. With the saturated cycloalkanes. We discussed this one earlier, Abby. What we said, alkenes are what there, cycloalkanes are what there, isomers. What kind of isomers? Functional isomers. So if you're here earlier, we talked about it for now. All right. Note, or before the note, please, let me just express that point again. I said alkenes and cycloalkanes are isomers. Let me take an alkene. Let me say but1ene or butene. For but, I expect 4 carbon. 1, 2, 3, 4. This. Balance it up. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. This is but1ene. I'll tell you why the 1 is there. Let's look at this. But1ene is 1, 2, 3, 4. C4. 1, 2, 3, 4, 5, 6, 7, 8. H8. It still satisfies this formula. Cn, when n is 4, it becomes H into 2 times 4, 8. This one here is an isomer of a cyclobutane. 1, 2, 3, 4. So this is cyclobutane. Balance it up. 1, 2, I have 3, I have 4. 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 It's a cyclo compound. Why? It's in ring form. This becomes cyclo number 2. I have 4 carbon atoms. That it becomes a but. Number 3 is single bonded throughout. That's an alkane. So cyclobutane. What I have here is 1, 2, 3, 4. C4, 4 carbon. I have 2, 4, 6, 8. So observe that the cycloalkanes are isomers of their corresponding alkene. So please take note. That means an isomer of propene is cyclopropane. An isomer of octene or oct1ene is cyclooctane. That's the idea. All right. Note. The first member of the alkene group, or alkene. The first member of the alkene group is ethene. is this is ethene. So the first member of the alkene is ethene, comma, put it in quote, methane does not exist. Please note that methane does not exist. Methane exists, methane does not exist. How? Use the formula there. The formula is CnH2n. For a met, C is 1, so it becomes C1, that's perhaps C, H into 2 times 1, 2. So let's say I have carbon H2. How? H and H. This is not balanced. In other words, methane does not exist. But then methane exists. Put this as 2. I have C2, N as 2. H into 2 times 2 is 4. So I have carbon, C2. Since it's an ene, I'll have a double bond. Then it has 1, 2, 3, 4 balanced. 1, 2, 3, 4 balanced. C2H4. So the first member of the alkene group is ethene, not methane. All right. Take down, take a note, one line space paragraph, one line space paragraph, one line space paragraph. Although the double bond is a stronger bond, although the double bond is a stronger bond than a single bond, yet the, write this one down, carbon-carbon double bond, yet the, write this one down, carbon-carbon double bond is much more reactive, than this carbon-carbon right there, single bond. As I said, the carbon-carbon double bond is much more reactive than C, just one. This red carbon-carbon single bond. Much more reactive than the carbon-carbon single bond. Let's look at the nomenclature of alkenes. How to name alkene compounds. Nomenclature of alkenes. All right, let's do nomenclature of alkenes. Please, the rule when it comes to alkenes changes. When we did naming of compounds, it was always an alkene. There's a reason why we did that. When it comes to alkene, the rule changes. Well, the rule remains the same. It is the priority that changes. Take down, please. When it comes to naming the alkenes, take down. When it comes to naming the alkenes, priority is given to the position of the double bond, not necessarily the substituent attached. Very important. When it comes to naming the alkenes, priority is given to the position of the double bond, not necessarily the substituent attached. So look up, let me show what I mean. Not necessarily the substituent attached. So put a full stop there and then look up again. Not necessarily the substituent attached. Put a full stop and let's proceed again. Continue, please. Add there. The position of this double bond is indicated using numbers. The position of this double bond is indicated using numbers. Example. Example, please look at this compound, observe carefully. Now listen. Normally, if this was to be my alkene naming, I would start from here because I have bromine. It will be this way. But when it comes to alkene, please, my focus on my priority is what there? The double bond. So when it comes to alkene, start from the part or from the way that will give you the lowest number to the double bond. In other words, if I go this way, I'll have 1, 2. 2 for bromine, 3, 4. 4 for double bond. If I go this way, I'll be having 1 before the double bond, 2, 3, 4, 4 for bromine. Please, my priority is the what? Double bond. So I'll number it in such a way that the position of double bond becomes the smallest, which will be this way: 1, 2, 3, 4, 5. Why? I want the smallest number for my double bond. In other words, the number of this number becomes from here to here 4 bromo. 5 is what? Pent. I said show the position of the double bond using numbers. This one is attached to carbon what there? 1 in. So it's called 4 bromo pent 1 in, or 4 bromo 1 penting. So I have this. That's the name, please. 4 bromo pent 1 in, or 4 bromo 1 penting. See the way I play with the numbers. See why I play with the numbers. Please complete the structure on your own, please, and give the name, please. Complete the structure on your own and give the name, please. Let's get this done. Hold on. So, it's okay. First task, complete the structure. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. How do you number this? Number it in such a way that the smallest number should be attached to the carbon bearing the double bond. The double bond is the priority over other substituents. If I start from right to left, I'm numbering 1, 2, 3, is carbon 4 that bears the double bond. If I start from left to right, I'm having 1, 2, 3. It's carbon 3 that bears double bond. Between 4 and 3, the smallest there is 3. Hence, I'll number this way. So 1, 2, 3, 4, 5, 6, 7. So I have this. Alright. Having said that, what next? My substituents here, bromine, chlorine, iodine. I will take them according to alphabetical order. So B first. That becomes what there? 6 bromo, 2 chloro, 5 iodo, 7 is hept. Hept 3 in, or what's that? Or 6 bromo, 2 chloro, 5 iodo, 3 heptene. So I said always observe the way we play with these numbers. Take the number in between the stuff and the in, or before any of them. So I have this. Let's try one more example before we move on, please. One more example before we move on, please. All right, copy this down, complete it, and give the naming, please. Copy this down, complete it, and give the naming, please. Copy this down, complete it, and give the naming, please. So let's get this done. First things first, complete the structure. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Complete. 1, 2, 3, 4. Complete. 1, 2, 3. One more. 4. 1, 2, 3, 4. So I have this. All right. Having done that, observe something. Observe that if I count from left to right, I would have 1, 2, 3, 4. The fourth carbon bears double bond. If I count from right to left, 1, 2, 3, 4. The same fourth carbon bears the double bond. In a case where from both sides is 4 and 4, that means double bond is no longer what there, the priority. You now focus on the substituent. That's the idea. So if I now focus on the substituent there, from here, of course, I'll get the smallest number to bromine. So in other words, I'll now count 1, 2, 3, 4, 5, 6, 7, 8. What I am stressing here is this. Don't go and say both sides are equal. So let me just come from here. The same thing. It's not the same thing. In the case where it's 4 and 4, focus on the substituents there. That's the idea. All right. So name is what you get there. Starting from the inorganic, that's your halogens. Bromine, what got there? So 2, 3, what there? Dibromo. 4 chloro. 3, 6. 3, 6. Dimethyl. Methyl what? Hold on. That becomes oct. 8 is oct. Oct what there? Oct 4 in. Or 2, 3 dibromo. 4 chloro. 3, 6 dimethyl. 4 octene. All right, so that's the idea there, please. That's the idea, please. Look up, please. Next up, please. Let's look at some special nomenclature. Let's look at some special nomenclature of alkenes. The first set of special nomenclature we consider is the cis-trans system, cis and trans system of naming alkenes. That's from the concept of what there, geometric isomerism, which we did last time. All right, just do some few examples and move on, please. So I could look at this. Look at this, please. All right, so look up, please. Look up, look up, look up. So, easy to get. Listen up. Easy to get. I said, in a case where, depending on what you want to focus on, whether the alkyl groups or the hydrogen, if they are like this, I said the idea is simple. Trace them. If I trace this, is forming this core. That's what there is cis. So it becomes cis. Cis what? Now hang on. How do you get the next thing there? I have two carbon here. So two, this one here, three, this one here, four, this one here, five. In total, I have 5 carbon atoms here. In total, 2, 3, 4, 5. 5 is what there? A pent. So 6 pent, pent what? My next step, I must ask myself, where do I count from to get the least number to double bond? If I count from here, this 2 carbon here, so carbon 1, 2, and then what again there? 3. Carbon 1, 2, 3 before double bond. If I count from here, I have just 1 carbon here, so carbon 1, 2 before double bond. Counting this way, I'll count 3 carbons before double bond. Counting this way, I'll count 1, 2 before double bond. So I'm using what there? The least, which is what there? 2. 6 pent 2A. That's simple. In a case like this, where I say they are at opposite ends, it becomes what there? A trans. Right? Here and here, opposite. Trans. I said if you follow it, form a T, as we did in the previous class, it becomes trans. Trans what? Count total carbon atom. 2, 1, 2, 3, 4, 4 plus 3. How many there? 7. 7 is what there? Hept. So trans hept. Hept what? Which of them gives you the smallest number to your double bond? This is 3 plus 1, 4 to double bond. This is 2 plus 1, 3. Between 4 and 3, 3 is the smallest. 6 have 3 in. Trans have 3 in. So this is how you name this one. Let's move on, please. Question. Okay, so listen up, please. He's saying from your text, this man comes with a hyphen, something like this: cis hyphen pent 2 in, like this. Alright, so that's what's there. There's no problem. You can feel free to use that one. So to small letter 2, small letter 2, that's trans hept 3 in this. Well, okay, no problem. But I don't think it's a major problem there. You already know how it looks like. So if your text says it's like this, there are no problems. Just do it there. It's not a major problem. At least you know how it's named. Just put hyphen, use small letter. That's all. Let's look at the next special case called the easy nomenclature of alkenes. So look at the next concept there. Easy nomenclature. So listen up, please. Listen up, listen up, listen up. We'll keep the same examples and use them as a reference for our next special nomenclature. The next special nomenclature is called the easy nomenclature. E and Z. E and Z. Nomenclature. All of you want I wrote easy. Not easy, oh. I mean E and Z nomenclature. So easy nomenclature, please. Let's look at this. Think about please. The E and Z nomenclature can be used in place of the E and Z nomenclature can be used in place of the trans and cis. The trans and cis system. The trans and cis system. The trans and cis system respectively. The trans and cis system respectively when an alkene does not bear two identical groups. When an alkene does not bear two identical groups. Does not bear two identical groups. All right. So I said E and Z. E, Z. I said can be used for which and which respectively? Trans and so E is for trans, Z is for cis. That's the first one to show you here. E is for trans, Z is for cis. Now listen. Listen, please. Listen, please. When we did cis-trans system, we had two alkyl groups at this position, and here was hydrogen, hydrogen. What of a case where we now have three alkyl groups? Of course, it's no longer cis and trans. It now becomes the easy nomenclature. How do you use easy nomenclature to name this? Look up, please. That's how it works. That's how it works, please. First things first. Follow my rule 1, longest continuous carbon chain. It's either I'll go the cis way. For cis way, it's like this, as we know. This cis. For trans way, it's like this. Obviously, my longest continuous carbon chain is starting from here to this point here. Because in total, I have 2, 3, 4, 4 plus 3. How many there? 7. So this one becomes my longest continuous carbon chain. So if I have this one here as my longest continuous carbon chain, and we say is 7. 7 is what? Hept. Of course, functional group, double bond is what there? Alkene. This one here now becomes what there? Is substituent. But then it's a special kind of substituent. So since on a normal, this should be my what there? Trans system. For a trans system, the equivalent of trans in the easy system is E. In other words, this one here, then becomes E. Okay, now listen please. Then becomes E. So see the way I write this please. E in brackets. Next up, I want to write methyl. But of course, I have to show the position of methyl. Listen and listen carefully. I want to write methyl, but I will show the position of methyl. But of course, this is again an alkene. And in my alkene, we said my priority is what there? The double bond. So where am I numbering from? Is it from A to B or from B to A? It has to be A to B. Because from A to B, I'll have the smaller number to double bond. From A to B like this, I have 1, 2, 3. It's carbon 3 that bears double bond. From B to A, I have 3, 4. The smaller one is A to B, so I'm having 1, 2, 3, 4, 5, 6, 7. Please. 1, 2, 3, 4, 5, 6, 7. So this now becomes E because E is the trans equivalent. So E, this one here, 4, the substituent there, methyl. So E4 methyl, 7 is what's there? Hept what? Hept what? Hept 3 A. That's how you name this. Now relax, relax. Let's go back again and then we are done. Relax. Let's see something here. Please confirm this is correct. Confirm this is correct. See if the is correct. All right. Let's name this one here. Look up, please. Obviously, longest continuous carbon chain has to be this one here. This one here. And this is what there is cis system. Abi? If it's cis, what will be the corresponding E or Z? So it becomes Z. My substituent, this one here, what is this? Ethyl. So the question is this: where do I take my numbering? Call here A, call here B. Am I numbering from A to B or B to A? A to B, of course, because this is 3 plus 1, 4. That's the shortest. So I'm having 3, 4, 5 plus 1 there. Okay, hold on. How many carbon in total? 10. 10 is what? Is deck. That's root 1. Root 2, functional group, double bond, alkene. Alright, so let's play with this. So I'm having Z, which is the cis equivalent. This one becomes what we call the substituent. That's ethyl. Ethyl is attached to which of the carbon there? Carbon 5, please. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how it's done. So it becomes Z5 ethyl. Ethyl what there? Deck what? Not decino. Deck 4 in. Or you can call it Z5 ethyl 4 decene. How do you call this? It's decene now. Decene. What do you call this? Decane. What do you call this? Decane or decene? Decane. What do you call this? Okay, so it's called decene, right? Sorry, this is called decene, right? Yes. I don't know why if it's decene. If this is Beck, it's called Becky, not Bessie. Becky. So deck, decene. Right. So it's called decene. All right. So decene. Okay. E5 ethyl deck 5 in, please. That's the name. All right. Moving on, please.
Alright guys, don't forget that you can get the complete organic chemistry course on my website. Simply visit www.jonahemmanuel.com/courses and then you see the organic chemistry full course. Alright, it gives you access to my detailed lecture on all the homologous series from alkanes, alkenes, alkynes, alcohols, ether, esters, including their nomenclature, their preparation, and all the reactions they undergo. Alright, or you can simply join my organic chemistry channel membership to get access to these video lessons. Alright.